Okay, Trig, this is actually the last section of chapter 8 already. Um, and so we're to the end here, but I am going to take this one and split this up into two videos again. So we'll only probably get through like example 1 and maybe example 2 on the second page. And then I'll do 3 and 4 for the next video. So this concept in section 8.4, we've already done this or already talked about this in chapter 7. It was like writing sine and cosine functions, where we talk about amplitude, period, phase shift, vertical shift, and we put them into the A, B, C, and D here. Okay, so this is going to be kind of a review for that. But this was kind of a tricky concept, so kind of be careful as we're going through here. We're going to take some actual scenarios of things that are occurring, like Ferris wheels and things like that, and actually have it make us an equation for it. So we're taking kind of story problem things and putting them in here. So let's just review kind of over what some of these values are. So when you're finding amplitude, amplitude is just going to be represented by this number A here. But remember that amplitude, even though sometimes that number will show up as a negative, amplitude is a distance, so it is never negative. What the negative will do is, this is the graph of sine, it will flip him down the other direction, so he'll go this way instead. Okay. Phase. Let's go to vertical shift. These two are the two that I think are the easiest. So I usually do this one first, and then do this one second. Okay, because those are the two easiest ones. The vertical shift is just represented by that D value. So if it's a positive, it's going to be shifted up. If it's a negative, it's going to be shifted down. Okay. Then period is the third one that I usually do. And when you're figuring out that B value, or you're figuring out the period, you have to take 2 pi and divide by B. Now the reason I use 2 pi for both sine and cosine is because that's the period of sine and cosine. So to get the new period, you have to take 2 pi and divide by that value. Okay. And then the last one, which is the hardest one of the two, or of the four, is phase shift. And that is determined by this number C here. And to figure out the phase shift, this is left or right, is what phase shift is. Sometimes we'll call it horizontal shift instead of vertical shift. Left or right is determined by, you take negative C and you divide by B, and that will tell you what the left or right shift is. Okay, so just kind of remember from what we were doing, I don't know, in chapter 7, this is the graph of sine of x. Okay, he goes up to 1, down to negative 1, and his period is 2 pi. Okay, and he cycles that way. This is what cosine of x is going to look like. He starts at 1, goes down to negative 1, and comes back up to 2. So it's kind of like a different section of what sine is. Okay, and these are all called sinusoidal functions. For this section, or for section 8.4, we're only going to be dealing with the graphs of sine and cosine. Okay, and these are sinusoidal functions. They're kind of like wave functions. Yeah, the wave shape of the graphs of these functions is called a sinusoid, which makes them sinusoidal functions. Okay, so example 1, we want to write a sine and a cosine function. Okay, sine and cosine. So what I'm going to do is I'm going to do this off to the side over here. This is going to be sine. This is going to be cosine. And I'm going to list out my amplitude, period, phase shift, vertical shift for each one of them. And then we'll go down here and we'll list what the equation is going to look like. So amplitude, period, phase shift, vertical shift. Okay. Now for sine and cosine, if you don't remember from chapter 7, sine and cosine, when you're trying to write sine and cosine of one graph that is the same, you're just trying to write two different functions, the amplitude, the period, and the vertical shift will be the same for sine and cosine. The only thing that they will have different is this phase shift. Okay, it will be shifted one way or the other, right? Like this sine and cosine, their amplitude is both 1. Their period is both 2 pi. The vertical shift, they don't have any vertical shift here, but their phase shift, one of them is shifted over from the other. Okay, so that's the only thing that will change from sine to cosine. And that's kind of what we need to alter here. Okay, so looking at this graph, let's start with the amplitude. Okay, they give us this little dotted line, which is the midline. We call this the midline. Okay, so I guess right away we can tell that he shifted up 1 because it's going to go through 1, right? So maybe I do vertical shift is up 1. Okay, for both of them. So let's do plus 1. Okay, but from there, how tall is it? Okay, and you're not going from highest point to lowest point, okay? That would be from 4 to -2. That's 6 units, okay? It's not 6 units. The amplitude is only from here to the middle. So the amplitude is going to be 3. And that's true for sine or cosine, whether we're writing a sine graph or a sine function or a cosine function. Okay, then the period, okay, let's just look at this first section right here. So I have, if I start him here at the y-axis, okay, he already looks like he's a cosine function, right? Because he's starting up here at the top point, he's going down, and then he's coming back up, okay? So that's one full period, and this is kind of what the original cosine looks like. Okay, the original cosine graph looks like. So he makes one full period in the amount of 1 pi rather than 2 pi, okay? So my period is going to be 1 pi, and that's going to be true for sine or cosine, okay? Now I just need to figure out the phase shift. So I already kind of said that if I look at just the way that he's written right now, starting at the y-axis, he starts up at the top and goes down and comes back up just like cosine would, okay? So cosine is not going to have a phase shift at all. He's starting and he's looking like cosine, okay? Now, what they're going to do, let me get a different color here. Okay, for sine, I want to figure out where sine, what sine is, or where sine is starting, okay? So I kind of look at this little graph right here and I see that 3 pi over 4 is listed there, okay? And so what they're trying to get us to identify is that sine, his first period goes from 3 pi over 4 to this point. Okay, so this is what the graph of the sine function will look like. That's really a bad pen. I have another one around here. So, okay. So my sine graph is going to start over here at 3 pi over 4. And he's going to go up and down and come back up again. Okay, so basically my phase shift is shifted to the right 3 pi over 4. That's what I need to change about my sine function. All right, now, when we put these into the equation, there's a little bit more work that we have to do, okay? I'm going to start with the cosine function because he doesn't have a phase shift. So let's start y equals, I know I'm going to have cosine in there and some parentheses and some other junk, okay? So my amplitude goes out in front. This is going to be 3, okay? My vertical shift is going to be +1. Done, done. Those are both done, okay? Now, I need to have an x in here, or sometimes people will put theta in there, or t in there, or whatever, okay? But the number in front of here, this b value, is determined by the period, okay? But I can't just put pi in front of there, right? That doesn't go just in that spot. Period, this guy is going to be equal to 2 pi over b, okay? So I use 2 pi over b to get to that point, okay? So then I just need to figure out what b is. Well, what I can do to find b, or to get b by itself, is I could flip those two around, and b will be equal to 2 pi divided by 1 pi. Okay, if I flip those two values around, the pi's are going to cancel, so my b value is just 2, and there's a 2 that goes in front of there, okay? Now, cosine does not have a phase shift, so I don't have like a plus anything inside this parenthesis here. He is just done, and this is what my cosine graph will look like. So 3 cosine 2x plus 1, okay? Now, the beautiful thing about sine is that everything else will stay the same, except I will have that plus something inside of here, okay? So I'm going to start by writing out exactly what I have. I have 3 sine of 2x, and then I need to leave some space, plus 1. Okay, so he will be shifted to the right 3 pi over 4. Okay, now I can't just put plus 3 pi over 4 or whatever here. 3 pi over 4 is equal to negative c over b. Okay, and my b value, we just determined from the last problem, or from the last part, was the b value was 2. Okay, so I'm going to put that in there. I'm going to put that in there as 2. Okay, and then what I can do is I can cross multiply if I want to. So I'm going to do 4 times negative c and 3 pi times 2. Okay, 4 times negative c is going to be negative 4c. 3 pi times 2 is going to be 6 pi. Okay, and then to get c by itself, I would divide by negative 4. Okay, so c is going to be negative. If I reduce the 6 and the 4, this would be negative 3 pi over 2. Okay, that's what my phase shift is going to be. Okay, so I'm going to put in here minus 3 pi over 2, and that's going to tell me that I'm actually going 3 pi over 4 to the right, okay? To the right actually means negative when we look at him inside of parentheses, so that's why he is there like that. So when we have period and phase shift, we have to kind of work backwards a little bit. It's just a little bit harder to think about than amplitude and vertical shift, but that's what those two equations will look like, okay? So let's see, simple harmonic motion, motion that can be described by a function of the form of sine or cosine is simple harmonic motion. Any kinds of physical motion are simple harmonic motions. Okay, so this would be like any gear that rotates around in a circle, or a Ferris wheel, or anything like this. This is a bike tire. So we're going to do this. It kind of looks like a bike tire. I don't know, maybe it is a wheel of some sort. A wheel with a radius of 2 centimeters. Okay, is rotating counterclockwise at 3 radians per second. Okay, a free hanging rod, 10 centimeters long, is connected to the edge of the wheel. Okay, 10 centimeters long. That's how long this guy is. 10 centimeters. Okay, and remains vertical as the wheel rotates. So what's happening to this rod is, this is hard to show. Let me use my pencil here. This is hard to show you. So as it goes around in the circle, what's happening is that rod's going up, it's coming down, it's doing one of these. Okay. So basically, now I'm doing a circle, not very good. Okay, it's going up, it's coming down, so that rod is staying straight up and down, and it's just going up and down and up and down and up and down. Okay, so if I think about this in terms of time, okay, what's happening to the rod is it's starting here in the middle, and it's going up, and then it's coming down, and it's going back up to the normal position again. Okay. So even though it's going counterclockwise, like in a circular motion, if I do that with respect to time, over time it's going up, coming down, and coming back up again with respect to time. So even though it's going to the left, it's doing that motion. Okay, assuming that the center of the wheel is at the origin, so this guy's at the origin, and that P is at 2, 0 because the radius is 2. At any time, or at time t equals 0, find the function and describe the y-coordinate of the tip E of the rod at time t. Okay, so they want us to figure out an equation for this point E. That's what we're writing our equation for. Okay, so let's kind of figure out some of the stuff that they've put up into this paragraph here. 2 centimeters is the radius of the circle. Okay, so basically if I look at this graph, that means this is 2 right here. Okay, so what is that 2 going to represent? Okay, that's going to give me my amplitude. My amplitude is going to be 2. Okay, all right. Now, the way that they write this next part is 3 radians per second. Okay, that doesn't necessarily mean the period is 3 radians per second. That is going to tell me the rate of my period, which is kind of a weird way of thinking about it. Basically, they have already converted that to a b. Okay, so for the period, the b is already not 2, 3. The b value is already 3 because they give it to me as a rate, 3 radians per second. I know that they've already converted the period to units of time. So the b value is already going to be 3 when I write the equation in there. So they've kind of done that work for me. And then the last bit of information they give me is that the rod is hanging 10 centimeters. Okay, and I want to go by the tip of this guy. So this circle, or this sine function that's actually doing this, is not up here at the top. I'm looking at the rod, or the bottom of the rod, which is going to be down below here, and it's going to start at negative 10. Okay, if that makes any sense. So I'm looking at the tip of that rod rather than this point up here, which means that I'm starting at negative 10. So my vertical shift is going to be negative 10 units down. Okay, I do not have a phase shift, which makes this really nice. Then I need to decide whether this is going to be a sine function or a cosine function. Well, the way that it's written, if it's starting here at 0, it's going to be a sine function. Okay, it would be a cosine function, for example, if that rod would start here, because I would be starting at the top part, going down, and then coming back up. That would look like this, starting at the top, going down, coming back up. Okay, so that would be a cosine function, but we're going to do sine here. So I have y equals something sine, my parentheses, this is going to be minus 10 at the end here. My amplitude is 2. and then they've already have this set up as 3, as my b value is 3, so I just need 3x in there. Or sometimes they'll write it as 3t. Let's put t in there rather than x, because they're wanting to use units as t. Okay, so this is going to be my sine function for this dot, as that dot is moving up and down. Okay, so what is the first time that the tip of the rod E will be at a height of -9 centimeters? Okay, so what they're wanting us to do here is looking at this function, okay, or I guess down here, this starts at -10. They're saying -9 would be right above -10. At what point or how long does it take for that rod to get from there to there? Okay, it's going to hit -9 there, and it's also going to hit over here as well. And that's kind of what goes into section 8.3, why we had 2 values, you know, that were the same for sine. But they're only saying find the first one. Okay, so how long does it take to go from -10 centimeters down here to up here? Okay, so basically this rod will be hanging, and I want to know -9 centimeters instead of -10 centimeters. How long does it take for that wheel to rotate from here to here? Okay, so not very long, probably. What is the first time that the tip of the rod will be at a height of -9 centimeters? Okay, so using my equation, how do I figure out what that is? Well, I'm trying to solve for time, which means I need something to plug in for y, okay? And what I'm going to do is I'm going to plug in -9, because that's what I want my y coordinate to be. So -9 equals 2 sine 3t minus 10. And I'm going to just unwind this equation and solve for t, and then we'll be done. Okay? I'm going to add 10 to both sides. So this one I'll have 1 equals 2 sine of 3t. Okay, and then, let's see, then I'm going to divide by 2. So I have 1/2 equals sine of 3t. Okay, now here's the deal. Since the 3 is stuck inside the t, I want to get rid of the sine first. Not divide by 3, I want to get rid of sine first. So I'm going to do the inverse sine. Inverse sine. Okay, so inverse sine of 1/2 equals 3t. And then I'm going to take and divide by 3. Okay, so I'm just going to do this all at one shot and figure out what my time is. So inverse sine of 1/2, I want to be in radians, okay, because the units up here, that was 3 radians per second, so I want to make sure that I'm doing radians, okay. So inverse sine of 1/2, you do have that on your unit circle, I guess. We could have looked that up, but that's okay. Inverse sine of 1/2, and then I'm going to divide that by 3. So my time is going to be 0.17, okay? Now what the heck does that mean, okay? Time is labeled in seconds because that's what it was up here. So it will literally take 0.17 seconds for this wheel to rotate that much, okay? That is not a very long amount of time, which means this is probably rotating pretty fast, okay, because it's going that distance in a really short amount of time, okay. All right, so hopefully that made a little bit of sense. We're actually starting to take story problems and put them into equations so that we can solve for other things, okay. In the next video, we're going to talk about the spring bouncing. So we'll do the spring bouncing problem, and then we'll do example 4 as well.